Well, hey there, kiddos. Here is your video on multiplying and dividing exponents. We've got used to just some basic properties of exponents yesterday, powers of 10. We also talked about negative exponents and things to the power of 0, but now we're going to talk about multiplying and dividing. And when we do multiplying and dividing, multiplication has a couple of different rules that are associated with it. The first one's pretty simple. If you are multiplying things that have the same base, like right here I've got 3 to the second and 3 to the seventh, the base is the 3. As long as they have like bases, so you have more than one of the same base, then you're just going to add the exponents when there's a multiplication sign present. So this problem right here is going to become 3 to the 9th power because I'm just going to add those two exponents and keep the base. So it's the same here, and I know my numbers don't match because now all of a sudden this is number 4, but this next one is going to become x to the 11th power. So I will just add those two exponents. And then this next one with the 2's, we'll go back to some of the stuff we talked about yesterday, in that this 2 to the power of 0 makes a 1, so I can just cancel it out because 1 times anything doesn't change it. It stays the same, so it's not necessary anymore. And then I can add these two exponents. And so I have 2 to the power of -2 and 5, and when I add -2 plus 5, I get 2 to the 3rd. And this I can simplify easily. I didn't simplify the 3 to the 9th because it's going to be a pretty big number, but 2 to the 3rd is just 2 times 2 times 2, which makes 8. And then this one over here, the -8's are in parentheses only because we want to show that the negative is part of the base. There is a huge difference between the negative being in parentheses with the number and it being outside, and we'll talk about that when we run across some. But this negative inside the parentheses becomes part of the base, so I end up with -8 to the 8th power. Just add those exponents up. Now, here is another rule, because sometimes it's not just strictly multiplication. Sometimes we don't just have a base times a base. Sometimes what we have is a base to a power and then taken to another power, like these next 4 problems. They're called the power of a power because I have an exponent to another exponent. And so what you'll notice is that I only have one base. Up here I had more than one. I had 2, this one had 3, but I had multiple bases that were being multiplied together. Here I'm only going to have this one base to this exponent, and when this kind of a problem shows up, when you've got parentheses with this exponent hanging outside it all by itself, you're going to multiply these two exponents. So up here, when you have more than one of the same base being multiplied, then you add them. When you only have one base but two exponents, you're going to multiply. So this becomes 4 to the 9th power. It's 3 times 3 makes 9. This one becomes x to the -8 power, and like we learned with our integer exponents, we can't leave this as a negative. We have to drop this to the bottom of a fraction, so the x to the 8th comes down here to become positive, and the 1 stays on top because there's, sorry about that bell, it's before school, it must be 8 o'clock. There's a 1 in front of that x, and so it stays on top because it's not part of the base. It's just a coefficient. And so this one, number 9, becomes y to the 12th power, so I have to multiply those two exponents. And this one, there's two sets of grouping symbols because we have the -6 in parentheses to show that the negative is part of the base, and then the brackets are just a second set of grouping symbols. You're still going to multiply the exponents, so this is going to become -6 to the 10th power. So that's how that works. And so this next problem is just asking you to extend that. They're saying that if y is equal to x to the 5th, I want to know what equals x to the 20th. And so what they're asking you is that if I have x to the 5th power, what power do I have to put it to so that this makes a 20? So what number needs to go here so that 5 times that number makes 20? Well, the only number that would work would be a 4. 5 times 4 makes 20, which means that y to the 4th makes x to the 20th. Because if I put a 4 on this one, I got to put a 4 on this one, so the answer is D. Now the next little rule is not really a new rule at all. It just is an extension of the power of a power. So like number 12 is a power of a product. The difference is now I have two variables, or I have multiple things inside the parentheses and then the exponent hanging out outside. I still have to multiply exponents, but now it becomes more like a distribution property. And so I'm going to take this 5 and I'm going to distribute it to everything inside the parentheses. So I'm going to distribute it to the x and to the y. So this is going to become x to the 5th, y to the 5th. And then I can't do anything else because x and y aren't like bases, so I can't combine them and multiply them together. I have to stop. The same thing with number 13. This little exponent of 3 has to go to every little piece in here, including that -4. And so I end up with -4 to the 3rd power, and then b to the 3rd power. And if I grab my calculator, and I do -4 to the 3rd power, that's 4 times 4 times 4, which makes -64, because that negative 3 times is going to be a negative. And then b to the 3rd. So that's what it simplifies to. Now when you run across a problem like number 14, it combines both the power of a product rule, so this where I have to distribute the exponent, and then the first rule we learned where we have to add the exponent. So order of operation says we always take care of parentheses first, so that's what we're going to do. We're going to take care of these parentheses, so I have to distribute it to everything. So this becomes 2 squared x to the 6th, because I have to multiply, times x to the -4. Well, then we'll simplify. 2 squared is 4. And now I have like bases with exponents, so I'm going to add up my exponents. So I end up with 6 plus -4, which is x squared. And so now this word problem down here wants you to write an expression to represent the area of a rectangle that has sides that have those polynomials or those numbers as expressions as measurements. Well, to find the area of a rectangle, we just do length times width. They're just asking you to multiply those. So I'm going to do 3 x to the 3rd y squared z times 6x y to the 5th z to the 3rd. And remember, when something doesn't have an exponent on it, like this x right here, that means there's an exponent of 1. We just don't write it because it's not necessary, but there's a 1 there. So we're going to multiply. Take your coefficients, the 3 and the 6, multiply them together, that makes 18. Then for like bases, so the two x's, we add up their exponents because I have two different like bases. I'm going to add the exponents, so 3 plus 1 makes 4. Then for the y's, 2 plus 5 makes 7. And for the z's, 1 plus 3 makes 4. This is the expression that represents the area of your rectangle. So let's talk about division. The division property of exponents is the opposite of the multiplication property of exponents. If you'll remember, the first thing we did, like bases, we added the exponents. So if I have more than one base and they are the same and I'm doing multiplication, I'll add up the exponents. Well, since division is the opposite of multiplication, when I divide like bases, I subtract the exponents. So number 1 here, they have like bases. So my base is going to be a 3, but now I'm going to subtract. 8 minus 2 is 6. So it becomes 3 to the 6th power. Now for a problem like number 2, the base is the x. And so I'll keep my x and subtract those exponents. 7 minus 3 is 4. But then this negative 3 over 15, these are coefficients, and I have to simplify that. And I usually do it by dividing, but since the bigger number is in the denominator, the division is going to make a decimal. So I'm just going to simplify that fraction. Negative 3 over 15, I can divide them both by 3. So this becomes negative 1/5 x to the 4th. Also, since this x to the 4th is positive, that means that I could also write this as negative 1 x to the 4th over 5. It's the same exact answer. I just, in one I keep the x to the 4th out to the side, and one I put it in the numerator. It's no big deal. Now number 3 combines some of our multiplication properties and our division properties, so it's a multi-step problem. This numerator up here is all good. I can't do anything with it right now, but the denominator down here I can simplify because there are parentheses. And I see that I have two variables with an exponent outside, so I have to distribute that exponent. So this becomes a to the 4th over b to the 4th. And then I have to subtract because that's what I do when I divide my exponents. So this becomes a to the 1st, so I don't have to put the 1. And then 9 minus 4 makes 5. So this becomes your answer, a, b to the 5th. Number 4 there is pretty simple. You can probably do it without my help. You're going to subtract 2 minus 5, which makes negative 3. And we know we can't leave that alone, so we're going to rewrite it as 1 over x to the positive 3. And that's our answer. So number 5 here has 3 different bases. It's got a 2, a 3, and a 5, and they all have matches. I can divide them. So we're going to do the 2's first. I'm going to do my 2's and I'm going to subtract. 3 minus 1 makes 2. Then I'll do my 3's. 2 minus 4 makes negative 2. And then I'll do my 5's. 7 minus 5 makes negative 2. And so this one and this one have negative exponents, so I have to move them down. Well, my 2 squared is positive. It's happy where it is, so it can stay. But then I got to move this 3 squared and this 5 squared down to the denominator. And all of this can be simplified because I know that 2 squared is 9. Sorry, 2 squared is 4. I know that 3 squared is 9 and 5 squared is 25. And so I can simplify that even further because I can get out my calculator and I can do 9 times 25, and I get that that's 225. That won't simplify any further, so I'm going to stop right there, but this is what that expression simplifies to. So now let's look at number 6. Number 6 also combines our division rules and our multiplication rules we were talking about. You have to get rid of the parentheses before you can do anything else. So this little exponent outside has to get distributed to everything inside, top and bottom. So this is going to become 2 to the 3rd power, x to the 9th power, because now we'll have to multiply them, over y to the 3rd and z to the 3rd. And then we know that 2 to the 3rd is 8, x to the 9th, over y to the 3rd, z to the 3rd. And that's all there is to that. Now a question like number 9, now I have a fraction and I've got an exponent outside. So I'm going to have to distribute this little exponent to both parts of that fraction. So I'm going to end up with 2 to the negative 3 over 5 to the negative 3. But now both of these are negative, and in order to make them positive, they're going to have to flip places. So I'm going to have to swap them, and I'm going to have to do 5 to the positive 3 over 2 to the positive 3 so that I have positive exponents. 5 to the 3rd is 125. 2 to the 3rd is 8. And there's my simplified expression. So number 11 down here, we have an expression, and then we want to know what's equivalent to it. Well, they just want us to simplify it. So let's start with what we know. 27 divided by 3 makes 9. So, and that's a positive 9. So B is automatically out because it was not 1/9, it's just 9. And so we're there. So now let's deal with our x's. I'm going to have to subtract the exponents. So I'm going to have to do negative 2 minus 5. And if you can't do that in your head, you're going to have to grab your calculator and type in negative 2 minus 5 because it makes negative 7. You have to be real careful here so that you don't make mistakes with those kinds of things. Then we'll do our y's. I have to do 6 minus 2. Well, 6 minus 2 makes 4. And the z to the 0 just makes a 1. I can get rid of it, which means anything with a z in it can go away because the z goes bye-bye. Which leaves me with answer choice C. Well, mine doesn't look like C, but that's because I have a negative exponent. So I have to keep positive things in the numerator and move the negative to the denominator. The answer is C. So one last question, and then I'll let you go, and we'll practice this when you come to class tomorrow. So we know the area of a rectangle. Area of a rectangle is 10 x to the 6 y to the 4th square units. We also know the width of the rectangle. We want to find the length. Well, if this is my formula, and I know the area and the width, to find the length, I'm going to have to do division. So I'm going to take my area, and I'm going to divide it by my width. And so 10 divided by 5 is 2. My x's, if I do 6 minus 2, that's 4. And my y's, 4 minus 12 makes negative 8. So I'm going to have to move this. So I'm going to get 2x to the 4th over y to the 8th as my length for this rectangle. So that's multiplication and division of exponents. We'll practice this when you guys come to class tomorrow. Have a good rest of your day.